Hey guys, on today's podcast, I'm interviewing Mike Berman, an SRE of 2 decades, and he's working on some top secret stuff, but we're gonna get a sneak peek into his mind to see what he thinks about Kubernetes, Nomad, Argo products, and general observability techniques that companies could be implementing. This is the guy you need to follow. So let's bring him in. Hey, this is Mark Wagner, and I'm here with Mike Berman, and this is the Epic Podcast about SRE and dev work. Mike, tell us about what you've been doing.
I've been working in the SRE field pretty aggressively. If you even want to call it SRE, it's been called a lot of things. Evolved from just sort of operations, DevOps, but I've been doing it about 15 years. I've worked with companies from small startups all the way up to some of the largest companies in the world, and I've learned a lot of things along the route from a lot of educated people.
Wow. Cool, let's dig in.
I've worked with a lot of large-scale infrastructures, and I try to put an emphasis on monitoring, reliability, and performance, I would say, if you want to kind of sum it up to the 3 points or peaks.
Really cool. I wanted to bring you today. I want to talk about some of these questions that we got lined up, and some of these come from my partner at Gantry, and we want to know about things like the landscape, running Kubernetes, which is obviously the hottest topic, and site reliability, but not the only topic. Observability questions, and just a few other questions to send it off.
Okay.
So let's get started.
All right.
What is the value add of a container orchestrator like Kubernetes? Like, why not just have your system initiate all of your processes?
Let's see. I mean, I would say one of the main things is most systems, believe it or not, in production run at about 2% capacity. They have periods where they'll burst, but for most people, there's not a lot of multi-tenancy going on, and there's huge amount of resource being wasted. So with something like Kubernetes, you can take a single computer and kind of reuse it and get all sorts of, you can use, so if you have like 8 CPUs sitting on a single instance, and right now you're only using 3% of it, you could load a bunch of different tasks and workloads on there, and instantly just get a lot more bang for your buck for whatever infrastructure you are running, even if it is bare metal, and you have Kubernetes on top of it.
So it's designed to play Tetris for you and make the most of your hardware?
Yes, exactly. There's also other things that happen. I mean, like if you're running containers, CI/CD gets much easier and sped up incredibly. I mean, there's a lot more reliability. If you're not really building images before you push them out, if you're just kind of running a init script, there's a lot more chance for error. So once you have this kind of uniquely built image or hash, you can now run all sorts of CI/CD tests and push it throughout your entire stack. So I think it opens up all sorts of things, and it makes a lot of complicated tasks much easier.
Wow, okay. Yeah, I found that doing everything through the same paradigm with Helm charts and YAML files, it became a breeze compared to managing things with different Jenkins and the various ways to run Jenkins, and it just turned into a nightmare. What do you think about Nomad or OpenShift? I mean, there's some other alternatives to Kubernetes.
I mean, I've never used OpenShift or Nomad. In full disclosure, I've used a lot of HashiCorp products, and I'm very happy with their approach. I know a little bit about Nomad as far as what they're trying to do, and it's interesting. I like how they handle some of the deployment methods. Just for me, I'm going to usually always try to lean to whatever is kind of the community standard at the time, the open source community standard. If you go look at like the amount of commits that are going on in Kubernetes versus Nomad or OpenShift, it's just way smaller. And then you also have just a much larger community of accessories, open source or otherwise, for add-ons, CI/CD tooling, stuff like that. So I just like kind of going with something that most people are using and there's a lot of support for.
I agree with that. I want to go with whatever has the most comments and most mentions on Stack Overflow.
Totally, that's where I'm going. Yeah. But I was really interested in Nomad, and I love what they're doing.
Yeah, definitely. I've seen that used for companies that have a lighter. They say it's simpler, but I think it's better just to go with what is the most used.
Yeah. Well, on top of it, I mean, I've heard incredible performance reports, but again, I've never tried it. But Kubernetes is building on top of Borg. So they have this huge history. So they've kind of piggybacked off of that, and all the lessons they learned within Google. So you're getting kind of a lot of experience within Kubernetes. And while it also has the community input of like things that the regular user needs, I think it had a big head start on Nomad. But again, I'm not using it, so I'm probably not the best person to speak on it.
Cool. Do you think it would be as successful if it hadn't been open source and built on top of board and everything?
No, I don't think so. I think that was the key to it. To get all the contributors and people kind of devoted to it and whatever, getting this force around the world, all kind of who really cared for it.
Do you think that's going to be the same for a lot of the other things that come with it, like Argo CD and Argo rollouts? Tools?
I mean, the thing is just Kubernetes is so centralized and has such a big backing, with kind of where it's from its origination. But so all these kind of other projects, like there's going to be several solutions in that space. It's very hard to see a clear leader. There might be one or the other, but I would say Kubernetes is just leaps and bounds compared to others as far as
yeah, everything built
community, in essence, of community.
Along with it, Terraform is more for it. Really, I found that it really only works well if you're using hosted. I mean, I have a friend who he works with me on some stuff. He builds. He does run his own kubeadmin, so he runs his own control plane. But he's also using Terraform. But it's not quite as useful as it is when you're dealing with one of the major providers.
Yeah, I mean, I think Terraform still has its use. I mean, you still need to do configuration management of your bare nodes if you're doing kind of your own administration. But I love it in the cloud. It's just it's a really good tool. And I don't even need managed at that point, honestly. As long as you just throw your configuration in like a shared space, like a bucket of some sort, so multiple people can push. It's pretty awesome configuration.
Wow, really cool.
Excuse me.
Let's see. Well, if I want to move an application from bare metal to Kubernetes, what things are the biggest considerations I should take into account?
I mean, these days they've got it pretty stabilized. Traditionally, bare metal will have these kind of monolith type applications where everything's running on single instance. You might have your proxy running on the same instance for fronting some web app of some kind, reverse proxy or something similar. All sorts of, you're going to have your Terraform running on the instance, all these different things. So kind of, I would say, narrowing your focus and producing apps or services that are easier deployable via container. So there is some issues there. Also, data migration can be an issue. Getting whatever, wherever you have your data stored, your persistence, migrating to the cloud. I mean, there's tons of solutions, so it's not the end of the world, but it's usually one of the bigger challenges.
That's my fear. I have a fear of losing databases and breaking them, and I guess that fear can be a little bit alleviated with the NoSQL ones because they're not even put together in the first place.
No, totally.
It's just.
But as long as you do good backups, and plan some, you're probably going to need some downtime. I mean, there are ways to do it with zero downtime. It's just going to make things a lot more complicated.
Definitely, yeah. I've heard there's been actually a return to monoliths now. There's becoming a return to it.
Yeah, I mean, microservices is hard to do right, but if you are doing it right, there's so many benefits. It's just so much easier to maintain and operate a small service and figure out what's going on with it, its current health. If you have, if it doesn't get too complex and too segmented, I think it's a great pattern. But if you're a small startup and you don't have the resources to monitor or kind of implement a microservice, I think monolith is probably the way to go. If you just don't have the resources or team to do it right.
Yeah, I once had a client that actually kind of was monolith in Kubernetes. They wanted everything to be in one Helm chart so that it all installs together in one thing. It's kind of like, well, I don't know, is that the point exactly of this, or of Argos to do it all?
So I'm not against that in some ways. So if you have independent kind of CI/CD chains on the versions that are pinned within Helm, then if you use Helm as sort of a state or a version, almost like a release tag in a way, I'm not against that. But I'm not a Helm expert either. But I could see where that could have its benefits, and you could do that effectively. All right? But you could really go either way.
But do you think that could maybe break, if certain open source things are updated, it's better to, because the big argument against that was that if some things are updated, they're open source, and you're pulling them in, they're not all internal, and then they're not updated consistently, like those should be their own individual charts, just so that...
Wait. So I might be losing you as far as...
So if like you have a large chart and it's has some things that are internal, like team built, and
right.
some things that are open source, not everything's going to get updated correctly.
Well, I think that's one of the things I think would be the advantage of the Helm chart, right? So you could pin each of these open source versions at specific hashes, and then you hold it there. So this Helm chart at this hash is one working, incrementing, whatever, build, release, whatever you want to call it. And if you added another step or if you did another release, and then you run all your tests and there's some issue, you can easily roll back to the last known working configuration. Yeah. So if you have a lot of tons of interdependencies and you need to make sure that you have to make sure that they all work well together, it seems that Helm could be used in that manner. There's probably lots of other tools to do it, but I could see how you could use Helm to get that done or whatever. Even if it was not your entire stack, but maybe large segments of it deployed via Helm. So maybe your persistence layer, and then this stack of services, your back-end services and your front-end services, all deployed maybe 3 different Helm charts, but all of them pinned because they have those interdependencies within those charts, I would say.
Wow. Yeah, I see Argo and Helm just go together like this, just with the version snapshots.
I'm not very familiar with Argo, but I'll check it out. We've been actually using Circle CI lately, which
okay, for the CI part of it.
Yeah, it's not bad, but there's some issues with the way we have it configured now, but specifically around build times and configuration changes, everything gets rebuilt, and I would prefer where the Circle CI was more handling the building of the images, and there was an independent deployment of the Helm charts, so you could have those sort of isolated, and you could have your images always being built. But if you needed a quick change for a one-off or something in production or staging, you could just make a configuration change directly to your Helm chart, push it out. No new images would have to be built, and you could be up and running very quickly without having to go through that process.
That's for if you're doing what's your Helm chart, like adding some variables, or
let's say DB host changes, or some endpoint changes, and traditionally you might have to rebuild the whole image to get it out, but now you can just do a separate configuration push versus just kind of breaking up your CI/CD in from where you can do light configuration changes versus actually going through the whole image build process.
Okay, yeah, I think you would like Argo CD then, because it doesn't do the building of the image, but it will as soon as it notices a change in the Helm chart in the Git, then it will go and pull that image from the Google Container Repository or
That's
wherever.
awesome. Yeah, that's really cool.
It is life-changing for me. Do you think using a managed Kubernetes service like EKS or GKE is a good idea?
Of course. You get so much for free, so much management, so much backup, so much reliability, upgrades, maintenance, security, all of that's outsourced. So again, if you're kind of limited on resources and you don't have a fully managed SRE and in-house security team, you might want to look at outsourcing it. It's just an incredibly fast way to get up and running. GKE, I think you're gonna, if you're looking for like a real Kubernetes experience, I think you're gonna prefer GKE over EKS, because EKS is, actually, I might be off on that. I think I'm thinking of ECS, their first implementation. EKS is probably I haven't used EKS. I've only used ECS, which was sort of their spin-off of Kubernetes. I really enjoyed Google Kubernetes Cloud, and I think it's pretty solid, to be honest. It's been very reliable and easy to maintain.
Great. Okay. Let me just check one thing real quick. Make sure our camera's recording. Okay, cool. We're good. All right. When do you think it makes sense to manage your own control plane? I know a lot of banks and large organizations will do that.
Yeah, I would say when you have, one, the team to support it, first of all, and 2, the real need for it. I wouldn't do it just because I had the team. I think the need for it would be something where you're in the financial world, where your security concerns or your compliance concerns will not let you work off of a cloud. Also, if you're running things at extremely large scale, you could probably get cost savings from running it on your own infrastructure or whatever it is. So I think there's some scenarios, but I think they're pretty rare. I think there would have to be a very good, strong use case for me to steer away from using a managed service, to be honest.
Yeah. How important is setting limits and requests on your resources?
That's super important. So if you're going to have SLAs or any kind of consistency within your app, you really have to know, you have to be able to just kind of return errors on let me think how to say this. So in essence, you want to have a predetermined amount of requests that a specific service can handle at any given time. So if you get saturated with requests, you want some sort of front service, whatever it is, that will handle these errors and take the load off your back end, and it can just be considered unhealthy, and it's not going to handle any more requests. If your service starts having troubles and it's getting overloaded and you continue to send requests, you're just going to continue to denial service yourself, and you can't even maintain the connections you do have. So having service limits and these kind of things is just all part of performance and reliability as far as knowing what you can handle at any given time. It's also really important for like cost estimations and scaling as far as provisioning and knowing what kind of services to implement when and where, I would say.
Okay. Yeah, I mean, because sometimes it can be a hang up when you do have those limits in place. You got to go and fix something, especially a resource limit. But then again, I guess you could have a runaway budget.
Yeah, and I would say you would want, if you do have these limits in place, so depending on the service, like if you start approaching your limits, you're going to want to start scaling. If you start hitting your actual scaling limits, then you're going to want alerts to fire prior to that. So you want something in place where you would be alerted when you start nearing your capacity limits. And then you'd want to provision and kind of reassess. Do I need to rebuild this service to be a little more efficient, or should I expand my capacity? So yeah, I mean, you got to have service limits also for like just pure denial of services. You could have malicious hackers or someone who's trying to mess with you, and if you don't have your service limits in, they can just very quickly eat up everything you have running and create a denial of service for all your users.
Wow. Okay. So you want to like limit it to different like service groups or different IPs or something like that? How would you limit it to avoid it? Because if you have a limit, wouldn't that make them more able to block you out?
Well, yes, in some ways, yes, absolutely. But so that comes into another. So if you start actually having denial of services problems, there's lots of services and applications that can act as basically web application firewalls. They're intelligent. If you're using one of these managed clouds like Amazon or Google, you're getting that for free. They have these teams that are extremely adept at denial of services. They can identify it at the source and block it at their low-level router. So a lot of times this is going to be something that, unless you are really specializing in this, you want to outsource this if possible. I mean, if you got a whole team, great, but the actual fighting of denial of service attacks, you're going to have to get some sort of device in place. But yes, either way, denial of service is going to knock you out whether you have the service limits or not, because your service limits are usually tied to what that thing can actually respond to in a reasonable amount of latency. So if it's getting to the point where they're hitting you and you're just taking all these requests and you're just taking forever to respond, you've still effectively been denial of service either way, even if it's just you're handling way less requests.
Can you re-explain to me how if it's a limit, then that means that if you have a resource limit, it's more possible for them to do a DDoS because now you can run at a limit and then it won't hit them.
Well, yeah, absolutely. I see what you're saying. Like that's a very real scenario. So, but the thing is if you've already established your service limit. So, for example, if you have a service that if it exceeds its quota, let's say you say it can handle 100 requests per second, and all of a sudden you start getting 150 or 200 requests per second. Now what happens is you might be oversaturating the downstream database. You might be oversaturating your cache layer. You might be oversaturating all these things. The requests, it keeps overloading requests. On top of that, it's going to be generating massive amounts of logs. So you've got all these things kind of going in. So you want a set of armor or a service that can handle this. Now, of course, web application firewalls are great, but not everyone has those, and most people don't, to be honest with you. But even just a load balancer, a cloud-based load balancer, you get all these things for free. And the load balancer is going to take care of it. So they'll respond cleanly and intelligently, throwing logical errors to your users.
Well, is this the red use method?
What's that?
Is this like related to red use?
I don't know what that is.
Oh, we'll get into red use. But basically, it's better to have something stay stuck on the client side than to get passed downstream into.
Yes.
Because
and you also the client also can now respond with a reasonable error, because it's now gotten something that it can understand versus just sitting there and having the user wait endlessly. You have reasonable limits, so you respond in a reasonable amount of time and display an error. You see, this is very common for large providers. You'll see it from Reddit and Google. If they can't handle a response, you'll see a very clear error. It very rarely will just sit there and time out forever. They're going to display you some sort of 500-based error. So these service limits kind of tie into that and allow you to kind of know when to return the errors. It keeps everything in line. So when an event does happen, not only that, it gets logged now. So now you have clear errors kind of being returned, and you can see a spike in errors. Alerts should be going off. Your team should be responding, and you should be dealing with whatever you have to deal with from an infrastructure level. Okay,
so even if you're a small business, it's important to start setting resource limits.
Yes.
Especially Kubernetes, where it's made not too difficult to do.
Yeah, absolutely.
This is a fun one. What are the benefits of relying on eventual consistency versus linearized or strong consistency?
Well, this is just old school question of CAP theorem in essence. So,
CAP theorem?
Yes. So consistency, availability, and partitions. So how do you want to handle the three of those? And you basically have to pick two. So if you want A good example of this was a story I'd heard. I think I saw this on YouTube. They were talking about two ATMs, and you have a small network of two ATMs, and you have to be able to return the balance. So in a perfect world, you could have local copies of the balance on each ATM. You make a withdrawal from one of them. The other ATM communicates updates the balance on the other one, so everything's nice. But what happens if there's a communication, like one of the ATMs are down, or both of the ATMs are down, or the connection is down between the ATMs? So now you have to start making choices of what you're going to do when these things go wrong. So in eventual consistency, what you're going for is you want way more availability and higher performance at the cost of consistency. So you're sort of making the trade-off, sort of like, well, I can go take $10 out of this ATM. It's going to drop my balance on this single ATM, but since the connection's down, it has to wait till the connection comes back up before it can re-update and then bring it down. But if someone checked that balance somehow in that other instance, when the connection's down, it's going to be at 200. It would be at its original balance. It wouldn't show the $10 debited from it. So there's all sorts of trade-offs and different things you can deal with, and it depends on what you're trying to do. Some operations have to be transactional, ACID compliant, and there's no room for eventual consistency, and there's certain things where people like to do that. So I think it really depends on what you're doing. I think if you can, eventual consistency is the way to go. It's way faster, way more reliable. But you can't get into race conditions where certain apps is just not acceptable for certain use cases.
So to put that in simpler terms, basically it's better to have these protocols that it just works well, even though it's not consistent, and then eventually you can add the average performance becomes the consistency. It becomes consistent over time.
Yeah. So let's say I'm making a write to a database, and this database is replicated to 7 regions around the world, and when I make this write, I want it to be consistent, which means I can't return an OK that this thing has been written until I get confirmation from all 7 databases. So there's a lot of latency involved in that. And even if you send it out in one big kind of broadcast and you wait for the responses, you're waiting for all of them. If one's operating slow, that's impacting the performance of this single write. In eventual consistency, I'll just say, hey, I got it. And there's lots of trade-offs. So there's some where you can write to, you want a quorum, you want at least a majority, or I just want at least 2 nodes. It's just everyone has, some are just, I don't care, just give me a write. So it depends on what you're doing. If you're doing some kind of event logging, and you're not worried if you actually lose a record every here and there, like 1 in a million, it's okay, or 1 in 100, it's probably something around 1 in a million. Then you could, eventual consistency is fine. It's not a big deal. And the truth is, it very rarely will completely disappear. The truth is, there'll just be race conditions where people are making requests to a specific node that hasn't been updated yet. So think of things like Reddit comments section, right? We don't care if that's eventually consistent. We don't care if if I'm Reddit, I don't care if the user who's coming there is seeing comments from 15 seconds ago. That's okay with me. That's fresh enough. And if he refreshes, he might see another interval of 15 seconds. But he does not need it doesn't have to be transactional where someone makes a comment and in real time that thing is pushed up onto his screen. It's not required for that. So that's an example where you could be a little more lenient on your your consistency.
In what cases would you want to use linearized consistency? Those would be let's say a finance transaction where it's very important that the account balance is not written twice.
Yeah, absolutely. So a financial transaction where maybe you're deducting from one account and inserting into another. So if the deduction works and then the insert fails, it's not really fair that this guy has been deducted, so it needs to be some sort of ACID compliance where you can roll back transactions. You'll be able to roll back the whole thing if a subsequent step failed. Games, some types of game scenarios where the timing is very important and you can't use eventual consistency. You have to actually know the state of the game at any given time. So there's lots of scenarios. There's only a couple I can think of off the top of my head, but.
Well, I think those are pretty much the 2 ones, because most things it's fairly, I always refresh Facebook or whatever app a few times.
Totally.
So observability, what are the risks of neglecting or failing to prioritize the observability of a system for those who think observability is a joke?
And that's actually more common than you would think, but you're just missing a whole bunch of information, right? So like if you're a small company and you just don't have the time for observability, which is a reality for some people. Maybe you're one guy and you've got a backlog that's 6 months long. Well, then maybe your method of alerting is the app's running slow or someone's complaining, right? That's going to be that's your observability, right? And the problem with that is you really don't have any ability to kind of forecast problems that are about to arise. With observability, you can see things as they start increasing over time. You're looking at it from a systematic way. You're looking at the whole picture in essence. And certain problems are so tied to system metrics, system performance, the network performance at the given time, or CPU and memory usage on the actual server that's hosting that service, that when you start trying to diagnose problems, if you can't correlate the network performance, you're in big trouble. You don't know why things are happening. They're going to appear intermittent or other kind of strange things will happen. You have no ability to track it down. But if you can correlate that weird app crash to a memory of 100% usage on some pod, it's pretty useful. So by making sure you have good logs from your app on error handling and making sure that all your errors are logged and you can correlate and actually search them together, it's pretty important.
Would you say that some of the Silicon Valley companies like Google, they can actually predict like, okay, tomorrow it's this holiday and we're probably going to have an overload of this service, or well, they
for
Google,
sure. Yeah, they're going to know. They like for the most part, but so Google's in another league, so they have so much resources. They can handle overflow, but even their internal teams have to kind of ask and request for specific service, and they'll hit service limits. You can't just build a server; they're not going to let you run wild, even in Google. So, I mean, they can definitely predict when a service is showing signs of stress way before it's actually visible to the user.
So basically, driving a car, looking through the windshield is using your observability. Driving a car, feeling what's in front of you at the bumper is not using your observability.
Yes, exactly. That's a great, like, hey, we just ran over someone. Be like, okay, well, let's try to fix that. Instead of saying, I see someone coming. It's exactly.
What was that movie where if you look, the demons like making it work fiercely? They had like the car completely masked up and they were driving like with the backup camera.
Oh, I don't know. I don't know.
Oh man,
I don't watch a lot of horror movies.
Okay, so how can I achieve full observability? What do you think of Prometheus?
I like Prometheus. It's just it's kind of complex. I think it gives you everything you need, but it's pretty complex and it's not so easy to manage. I'm not quite sure what EKS, what metrics you get exposed on EKS and AWS, but GKE, I believe they are running a version of Prometheus. I think GKE has their own instance of it running. I'm not 100% on that, and it'll export metrics right from the cluster right into Google Cloud metrics, which just makes things a lot easier, right? There's so many layers I'm removing, and I've got so much I can just concentrate on actually writing my rules for my metrics instead of the whole system of running the metrics. So for me, I prefer going that route if possible. I've done that in AWS also, not with GKE, not with Kubernetes, but with all the other services. And worked really good, honestly.
Fantastic. Really well. Yeah, I mean, I use PromQL, and one of the things we're working on Gantry is a dashboard that provides some recommendation engine, and it uses Prometheus metrics. And if there's a metric that we want that isn't generally, pulled by regular nodes, then we'll add it. We have our own thing to pull application metrics and put it in. So that way we can kind of compare those to the infrastructure metrics that Prometheus pulls by default. Okay.
Yeah, that's very cool.
And I want to know, but I agree. It could be easier. It could be easier to use for sure.
Well, so to give you an example, like I need to export some metrics. So the standard way with Prometheus is you make a Prometheus endpoint, you expose your metrics. I'm talking about custom app metrics. There's also a lot of libraries where you can just export your metrics directly from your app. Mm-hmm. So in each request, you're kind of pulling them. Okay.
Companies seem to value SLOs and SLIs. What do you think about the use of these, and is there a better alternative?
I mean,
for those of you who don't know, that's service level objectives and service level indicators.
I think they're good. I think they're really good. You can call them really whatever you want, but you need something to kind of track your metrics. You need some number to kind of know how you're doing, a benchmark of whether you're above water or below. And SLOs are really good for that. You don't have to actually put them into agreements. They don't have to be contractual, but you should have something similar to that of what you're trying to obtain with each endpoint for the latency, I would say.
Okay. Yeah, I think that's kind of, if it as it like falls into Scrum and all the other things, like there's time-based goals and then there's resiliency and like consistent goals that are always trying to be met. So for us, and for a normal engineer, there's like, okay, this is what we want to get done at the end of this sprint. But for us, it's more like this is what we want to see throughout the year.
Yes, yeah, absolutely. And more specifically, we want to be able, like, if something's within its SLO, everything's running fine, I don't even have to know about it. It could sit there and run. What I want to know is when it starts getting out of its SLO. So with the SLO, I can now start building alerts and monitors and all sorts of things that are based on that number, so I can actually respond when there's only a problem and ignore it otherwise, hopefully.
That brings us to the next question is, do you believe in error budgeting? And why would you want to budget your errors?
Do you mean something like like an uptime? Like a percent, like how many 9 uptime or reliability you're going to have?
Kind of, or like how many of a certain area you're allowed to have per month?
Oh, yeah, to a degree. I think I'm more concerned about error rates. And you don't want your error rates going over a certain percentage. If you're having some kind of consistent errors, I think you'd want to address it at a more systematic level. You'd want to figure out what's going on. Why are the errors being thrown? Are they being handled correctly? If they're legitimate errors that can happen, for example, it could be a session that no longer exists and you're throwing 404s or something along those lines. I don't know if I'd want to budget. But I'd want to know if anything changed from the norm if I'm now kind of getting out of our baseline.
Yeah, most errors, if there's an error, like a warning and error are two different things, right? But if there's an error, it's like they're like cockroaches. If there's one, there's probably many.
Yes. So we should be responding to our errors in a pretty quick method. We want to know when they're happening, and the budget should be as low as possible. Put it that way, if you're going to have one.
How should the errors be dealt with? Do you think the SRE should go and try to fix the errors, or should that be sent back to whatever team was responsible for that source?
There's different schools of thought on this, but I'm a big proponent of having the stack owner handle the errors. SRE can route the errors, although errors really should ping someone who can actually take action on it. So the person who's carrying the pager, or the person who gets notified of the actual alert, should be someone who works on that team in some kind of rotation that can actually fix the issue as it arises, because they're going to be much better than the SRE. Now, if they need if they diagnose the problem and they track it down and they say, look, this is something with our load balancer, the load balancer is incorrectly handling this route, then the SRE absolutely has to step in. That's their territory. But if the SRE is determined that the errors are coming from the app side, the developer should pick it up, the engineer.
Or you could do what a lot of large companies today do, is that just email everyone.
Yeah, exactly. Someone pick it up.
Email the whole department.
Yeah, totally.
So how hard is Kubernetes really for engineers that are using Ansible and Jenkins and they're writing a lot of bash scripts and tying them together?
I don't think it's that hard. I think there's a lot to learn. I think there's going to be a learning curve. I think you're going to spend a minimum of 6 weeks getting kind of your feet wet and getting comfortable. But I don't think it's impossible. I don't think there's a huge barrier to entry, especially if you're using something managed.
Okay, you hear that? Let's jump in. I know there's a real lack of people that have Kubernetes experience right now, and I'm trying to figure out why that is, because I found it kind of pleasant to use compared to all the mishmash of different tech in the same space. It just covers so much ground.
Yeah, I like it too. I got to be honest. I've worked heavily in VM-based instances. I mean, in most scenarios, I don't know if you're going to get completely away from it. I'm also big into serverless. If you can do it, go for serverless.
You like PWAs, progressive web apps, and
yeah, well, yeah, where you you have a bunch of lambdas and some sort of front end. AWS has their gateway where you can front their lambdas with the gateway, and in essence, everything is tiny microservices, 100% hosted in lambdas. You have no infrastructure. You can scale unlimited, and in downtimes, there's almost no cost. It's unbelievably solid and reliable. A little bit of a learning curve to set it up, but there's so much documentation. That's the way I would go if I was on a very tight budget.
Okay, so that's what I'd say on a budget. And those just the scaling. Didn't you have to set budget requirements for each Lambda expression, or is it all handled?
No, it's all pretty much handled. You're going to have like base account limits on number of Lambda calls you can make, but you can get those expanded as your account grows, and if you're showing good kind of usage records, they'll keep expanding your limits.
Wow. Okay, and they bill you for more use though, just similar.
Absolutely. But that's what so if a specific function gets so large that it's actually cost prohibitive to run it on Lambda, that's when I would start looking at doing things along those lines. But for most small apps that are starting up or small services, they'll be nowhere near that kind of a cost. In fact, it's going to be way cheaper to not have an instance running all the time and just kind of outsource it to some cloud-based function.
Wow. Okay. And then, but then linking those together, they don't link as pointing to the server, but you point to basically the ingress, whatever Amazon provides for you. I think they have ARNs, right? That's how they.
Yeah, I think so. I know what you're talking about, but they have a gateway. They have an API gateway.
Yeah.
So the API gateway works like a real load balancer and it's fronted by CDNs, and then the API gateway is backed by Lambda services, I believe. I don't think it has to be only Lambda. I think it can be several other things. I'm not great with this. I haven't done tons with it, but the idea is that you can set up your full stack 100% serverless without having to run instances and manage them and all these things.
Yeah, last time I messed with this was when I was making Alexa commands.
Yeah, totally. Yeah, it's awesome. I've seen Lambda scale to crazy heights, like really large Facebook style traffic or levels of traffic, and it runs fine. It runs beautifully, actually, and you don't have to deal with one bit of that infrastructure, not one bit. Just watch your monitoring, watch your tasks, and all those things.
Are you as happy about Google's systems for that, the Google equivalent of Lambda? Or? Was it compute? I think it's
Cloud Functions. I believe it is. Yeah. So I haven't had as much experience with Cloud Functions as I have with Lambdas. But Google versus Amazon is interesting. It's some things Amazon does way better. They just have a lot more time. They've perfected it, but some things Google does in a much cleaner way. So it's neither here nor there. I'm very happy with both. I was super uncomfortable in Google Cloud at first, but once I got my footing, it's really not that bad.
Yeah, we got to not leave out the others. There's a Microsoft Oracle Cloud now. DigitalOcean has their own cloud.
What is that? What are these?
There are other.
Yeah, it's like the worst news I could get is going to some place that would say, "Oh, hey, we just got this huge discount. You're going to move to the brand new Oracle Cloud, and you'll be the guinea pig trying to figure out all the issues."
The new cloud is called the Storm Cloud. Yeah. It's going to rain on your day. Oh man, what do you think companies are lacking most when it comes to implementing some SRE practices? Just not having them at all.
Yeah, I think sometimes. So if an SRE is doing their job well, there's nothing happening and there's no events, so sometimes it's hard to see the value in it. But if everything's going wrong, if you just can't quite seem to get your reliability in place, errors are through the roof, downtime is just everywhere, you're having problems with your deployment chains, or your CI/CD chains, just nothing is working as it should, you probably want to focus more on you want to focus on reliability. You want to kind of take a new approach and kind of reassess what you're doing and make sure you're kind of just doing the basics. Just make sure you're doing the basics.
Well, yep. Just keep on. There are certain best practices that are published on how things should be done depending on the system you're using. And, like, for example, having multiple replicas of at least each service.
Yeah.
And if you follow those, then you're basically in good shape, right? There's a certain standard to qualify yourself. It's a benchmark. And that's what we hope to establish in the future, especially with what we're doing at Gantry.
And iterate. You're going to learn a lot. So every time there's an outage, just learn from it. Figure out what went wrong. Was the outage caused because you only had a single instance? Well, make sure you have two next time. Whatever the problem is, try to resolve it and prevent it from happening again, from recurring.
Sick. What do you think is next in the SRE space after Kubernetes? Is it too early to say? Or
I think, if I just had to take a guess, I would say heavily moving towards things like Cloud Functions, where every piece of code is extremely small and bit-like.
So not a monolith,
together. Yeah,
but more scattered.
In a sense, but with the aid of some monolithic service that helps you orchestrate all these things perfectly. So if you have some service that's going to deal with all that, all the middleman work, the sort of like all these problems you have with interdependencies and the performance of one downstream dependency impacting all the upstream dependencies and having troubles determining where this is occurring. If you have a system or an application that can handle that I think would be the next iteration in SRE, like the next Kubernetes in essence.
Wow, it's gonna get even more Granular.
Yeah, totally.
Amazing. Well, I hope you enjoyed our first segment of the podcast. We got to come up with a good name for this. What should we call it?
I don't know. Enlighten SRE.
Enlighten us already. We'll work on that. I was thinking something like along the lines of a Unix timestamp. And this is not going to be monthly or weekly because there's too much going on to schedule it particularly. It's just going to be whenever I'm with an interesting SRE that has a lot of things to say. It's just going to be a date stamp.
That's cool.
You know.
I have a friend who I think he's currently at Twitter, but he spent a long time at Apple and LinkedIn, and he is passionate about SRE and loves talking about it. So maybe I could link you guys up, and he'll probably be happy to help you out.
Fantastic. Probably get his info. I've got it. The Epoch podcast.
There you go. I like that.
It's going to be in Unix Epic time. And that's it. Hope you enjoyed it, folks. Catch you on the next one.